Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my wonderful students of Senior 1. How are you? Hope you're okay. Personally, I'm very okay, and I want to believe and pray that all of you are okay. I know you're keeping yourself safe. Continue doing that because the country needs you alive. I am Teacher JB, your physics teacher, and I'm very excited to be with you again today, as always, for the next 30 minutes of intensive interactive TV learning session. And our unit for today, as you know, all these days we have been looking at unit number what? Number 6. That's where we are. We have not moved to another unit. And this unit number 6, we are talking about work, energy, and power. Okay? That's what we are talking about. Work, energy, and power. Now, in the last lesson, if you remember, when we were looking at lesson number 2, in lesson number 2, we were still looking at work. Do you remember? We were still looking at work. And so today, we want to look at what we call power. Okay? Power. Power. I don't know what it is in Kinyarwanda, but you can find it out. I know there's a word called imbaraga. Is that energy or it is power? I think there's also another word which is called amani. So try to find out. If you get it, please make me know. But for us today, we want to look at power, which is a word I'm very sure most of you have encountered in your daily lives. Power. What is the meaning of power? That is what we want to look at today. As a country in physics, can we measure it? Yes. If we can measure it, then how do we quantify it? That is what we want to look at today. So in our lesson objectives, we want to be able to define power. We want to be able to derive the formula of power and also state the SI unit of power. We want to talk about the watt, because we shall discover the watt is the SI unit of power, and how do we define the watt. Then we shall look at the relation, how to use the relation P equals W over T to solve some numerical problems. That is what we want to do today. So make sure in these 30 minutes you are able to do that. Get your calculator, your notebook, your pencil, your pen, and your math set. They should be near you, and sit comfortably in front of your TV and take the notes. Okay. Let's remind ourselves of what we looked at last time. Do you remember? Last time we looked at work. And we said work done, if you remember, work done is equal to force times what? Times distance. That is what we looked at last time. Work done is equal to force times distance. And remember, we had a magic triangle. Me, I love magic triangle because the magic triangle, enables me to remember my formulas. This magic triangle, it is a very beautiful triangle. It helps me to remember my formulas. So I put something like letter T, like this. And so, if I want to remember this formula, remember we said here there is a multiplication sign. So, we are multiplying force by distance. To get what? To get work done. Magic triangle. Never forget it. Very easy. Maybe for a formula that you already know, I know most of you know this formula. Let me put it here. Most of you know this formula. That speed of a body is equal to distance, then divided by what? By time. Most of you know that formula. And some of you also use small d. No problem. So if I use small d here, so speed is distance over time. So if I cross multiply, even if I don't cross multiply, let me first put that t inside. So the t is going to be like this. And remember what comes here. What comes here is a times. Okay? That is what comes in there. And then, remember it is distance over time. So it means here I'm going to put distance. I can put time here or I can put time there. So if I put time here, then what we are remaining with is speed. So you say distance is speed times time. Speed is distance over time. And time is distance over speed. Is that hard, my wonderful young boys and girls of Senior 1? Should be very nice. So once you get a formula and you have 3 quantities, please try to keep your formula in the magic triangle. It's very important, magic triangle. You also have weight of a body is equal to mass times acceleration due to gravity. You remember that? When you are getting weight. So, again, in your magic triangle, it means you are going to have something like this. Okay. Here, you know, there is a times. We are multiplying mass by acceleration due to gravity. So it means mass has to be there, and acceleration due to gravity has to be there. And up there, what are we then going to have? We are going to have weight. So a very wonderful way of remembering that. So that's what we looked at last time, if you see on your screen. Then let's look at a question that will allow us to use that formula. Work done is equal to force times distance. So let's look at that question. It is question 4. Last time we stopped at question number 3. So this is question number 4. And by now you know what I need. You have to identify the quantities which have been given. If you can't do that, it means you have not understood the question. So let's identify the quantities given. A force of 75 newtons, that means here force is equal to 75 newtons. Okay? Is applied to a certain body placed on a smooth horizontal surface. If 0.72 kilojoules of work, so it means W is 0.72 kilojoules. Already when you see kilojoules, you must change it into joules. And changing it into joules means you have 0.72. Kilo means 1,000. So we multiply that by 1,000. And that is joules. And according to me, this is going to be 720 because the decimal point was here. We move it 3 places. 1, 2, 3. So it is 720 joules. Okay? Then we continue. Find the distance moved by the body. So what they want is the distance. What is the distance moved by the body? So we shall say, using the formula, work done is force times distance. Then you put your work done, which is 720 joules, is equal to force, which is 75 times D. Okay? And so, to simplify this, it means we divide this side by 75. We also divide this side by 75. So this cancels that. And I hope you are getting your calculators ready also. So we shall have D is equal to 720 divided by 75. Okay? So press your calculators and see what you get. Press your calculator and tell me what you get. It is 720 out of 75. So let me press it here also. 720 divided by 75. My answer that I'm getting here is 9.6. So it means D is 9.6. And what is the unit of distance? It is going to be meters. So D is 9.6 meters. Is that also what you got? If that is what you got, then that is wonderful. Okay? 1 minute, a few seconds for you to complete writing that. As I take details about question number 5. And question number 5 is already projected for you on the screen. You can see it there. A tractor's engine, you students know what a tractor is. And in that diagram you can see, in that picture you can see there is a tractor carrying a lot of sugar cane. So a tractor's engine exerts a thrust of 20 kilonewtons. Now the problem is thrust. Problem is thrust. When they talk of thrust, what is the meaning of thrust? Thrust means the same thing as what? As force. That's why we talk of upthrust. That means upward force. Upthrust. Like if you put something in water, there's a force which pushes it upwards. We shall look at that in the next unit when we are talking about Archimedes' principle. Oh, so that is the next class. Okay, so a thrust of 20 kilonewtons on a certain road on a given day. On that day, the total friction force on the tractor was 5 kilonewtons. So what does it mean? It means that F is 20 kilonewtons. That is our force. But again, I told you, change this into newtons. That becomes 20,000 newtons. Then the frictional force. Frictional force is given as 5 kilonewtons. And this is going to be 5 times 1,000, which is going to be 5,000 newtons. Okay? Then, if the tractor moved for a half a kilometer, you see, they are saying half a kilometer. Now, half a kilometer, it means it is distance. And so, distance is a half of a kilometer. But is the standard unit kilometer? No, standard unit is meter. How many meters are there in 1 kilometer? It is going to be 1,000. So we multiply this by 1,000. And that becomes, if you cross this very well, you are going to find how many meters? 500 meters. So the question is, calculate the work done by the tractor. So let me put just a small sketch here. Just take this as your tractor. The force, there's a force which is pushing it forward, and there's a friction. Friction is here. Okay? Friction is this one, which is Fr. This is friction. Friction is pulling it back. But the engine is pushing the tractor forward. So what force are we going to use? Are we going to use friction, or we are going to use the thrust? No, we are not going to use the thrust only or friction only. We are going to use the resultant of these two, which is the bigger force minus the smaller force. So we shall say here that work done is equal to force. Remember the formula. Work done is force times distance. Only that here our force now is going to be thrust, okay, minus what? Our force is going to be thrust minus friction. That is the force. Then we shall multiply this one by the what? By the distance. And so, this is now going to give us the thrust. Thrust there you can see is 20,000 minus the friction. Friction is 5,000. Then we shall multiply this by the distance, which is equal to 500 meters. Because newtons here, newtons there, meter. Everything is in the standard unit. Okay? Then, let's just try to multiply that. I hope you are getting your calculator. 5,000, if it is removed from 20,000, becomes 15,000. So I'm simply going to have 15,000, then times the distance which is 500. So I multiply that by 500. I'm coming out with 7,500,000. And that is work done. Work done must be measured in what? In joules. So it means the work done by that tractor is 7,500,000 joules. That's the work done by the tractor. Okay? That should be easy for you. Work done by the tractor. Right. So, as you finish writing that, there are some trial questions that I will love so much to leave you students with, to practice and see whether you have got the concept of work done. I am going to bring back that question, those questions at the end of our lesson. I will bring them back. I'll bring them back. But that's what I will want you to do. Those 4 numbers, trial question. I'll bring them back at the end of the lesson. So let's move to power. Power. Look at that on the screen. Do you see what is on the screen? A very, very powerful looking man. Those are called bodybuilders. Some of you must have seen people who look like that. It means they eat properly and they do a lot of physical exercise, which is good for your health. Okay? So you can be that powerful. You can look that strong with a lot of muscles. Now some girls are saying, no, that is only for boys. No. Even ladies can become bodybuilders. They do a lot of exercise in the gym and they keep fit. They eat properly. They eat well. That is good. And it is good for you to be strong. Good for you to be strong. Now the question is, that man who you are seeing on the screen, do you think is more powerful than the truck? You see that caterpillar truck? The tractor, which is used for grading roads, used for, scooping soil and lifting very heavy loads. Do you think that man, strong as he is, do you think he's more powerful than the tractor? I just didn't want to ask you, between me, I and that man, who is stronger? Because all of you know the answer. Me, I'm stronger than that man. Am I not? I think I am. I'm not even thinking, I'm very sure I'm stronger than that man. But between that man and the tractor, who is more powerful? So we can only answer that question when we know the definition, the meaning of the term power. Okay? It's not about the size of the person. No. You can be big in size and then you may be less powerful than someone who is smaller than you. So what is the meaning of power? That's what we want to look at. Okay, by the time you finish answering that question, all of you, looking at power, all of you will be able to tell whether that man is more powerful than the tractor. So what is power? Power is the rate of doing work. Can you say that along with me? All of you students, what is power? Power is the rate of doing work. Power is the rate of doing work. Now, in mathematics, the moment, even in physics, the moment you see, they are telling you about rate, rate, it means there's a quantity which has been divided by what? By time. And that's why, please come along with me here to the board. Power is the rate of doing work. We are saying power is the rate of doing work. Power is the rate of doing work. Okay? So if power is the rate of doing work, mathematically it means we shall have power is equal to work which has been done, then divide by what? Divide by time. Because I told you the moment you see that rate, it means you divide it by what? By time. Just like speed. What is speed? Speed is the rate of distance covered. That's how we define speed. Rate of distance covered. That means it is distance divided by what? Time. Is that okay, senior ones? Good. So power is rate of doing work. That means we shall have work done divided by what? Time. Let's use symbols now. What symbol do we use for power? It is P. What symbol do we use for work done? We have already seen that before. The symbol we use for work done is W. And what symbol do we use for time? It is T. And so this becomes our beautiful formula. Power is work done over time. Power is W out of T. You see, we have already talked about that. We are already looking at this. And so, what is the SI unit of power, therefore? Now, the SI unit of power, we shall get it from this. Work and time. So, what is the unit of work? Work is measured in what? Joules. What about time? Time is measured in what? In seconds. So it means the alternative unit of power is joules per what? Per second. You see? Joules per second. But before looking at the alternative unit for power, we shall see that the SI unit of power is called the watt. That's the SI unit of power. It's called the watt. And how do we denote this watt? The watt is denoted by letter what? W. Capital, not small. Use a capital letter. That is a watt. And this watt, me, I like using colors. 1 watt is equal to 1 joule per second, which you can also write as 1J, then S to power -1. Remember, it is small s. And some students like making a mistake. If you write this for second, that is wrong. In mathematics, sec is actually an abbreviation for a trig ratio, which is called secant. You are going to learn that when you are studying trigonometry. Secant. So don't abbreviate second as sec. No, this is completely different. The abbreviation for the symbol for second is small s. Don't put capital S. It is small s. So that's the meaning of 1 watt. So that if I say someone's power is equal to 10 watts, just imagine 10 watts. So if it is 10 watts, it means this is equal to 10 joules per watt? Per second. So if my power is 10 watts, of course my power is more than that. It would mean every second I'm using 10 joules. Remember that? Last time when we were lifting water from the ground up to the level of the mouth, we used about 15 joules. That is the energy I use. 15 joules. Raising water, 1 liter of water from the ground up to the level of my mouth. We used 15 joules. So if I say the power is 10 joules, it means every second I'm using 10 joules. So 10 joules per second becomes 10 watts. And on your screen, you can see other bigger units of watts. Kilowatts, megawatts, gigawatts. We have already talked about that. Megawatts means 10 to power 6. Gigawatts means 10 to power 9, which is a billion. Megawatts is a million. And kilowatts is a what? 1,000. That's why 1 kilowatt is 10 to power 3 watts. 1 megawatts, 10 to power 6 watts. And 1 gigawatts, that's a lot of work, a lot of power, which is 10 to power 9. Okay? So let's look at one question. Because remember, in our in our objectives, we were supposed to look at the watt and the definition of the watt. What, remember, rate of working of 1 joule per second. 1 joule per second. And so, lastly, we just want to look at one question so that we see how we apply the formula. Power is equal to work done over time taken. Then in our next lesson, we shall continue with many others. And so, question number 1 there is telling us, what power is expended? Now, to expend means to give out. So what power is expended is given out. This is under power. So they want us to get power. By a boy who carries 30 kilograms heap of wood. So mass is 30 kilograms. And automatically here, because we are dealing with forces, we must change that mass into weight, which is going to be 30 times 10. And that becomes 300 newtons. Through a height of 10 meters. So height, which can be represented by D also, is equal to 10 meters. They want us to find the power. So again, you remember power is equal to work done over what? Over time. But work done itself is equal to force times what? Distance. So we shall divide this by time. But because this boy is carrying some heavy load, that force is going to be equal to the weight. And weight is going to be equal to mg. And that's why this is going to be mg instead of force, then times the distance, then we shall divide that by what? By time. So mg is what we have got here. So that becomes 300, then times the height, which is the distance, which is 10, then divide it by the time. Time, I didn't note it down, but time is given as 10 seconds. So we shall divide this one by 10 seconds. Everything is in the standard unit, right? And because they're in the standard unit, we don't have to worry about the units. Mathematical gymnastics, the 10 will cross each other. Right? And when they cross each other, we are going to remain with only 300. And remember what we are calculating. We are calculating the boy's power, which is 300. And the unit of power is going to be watts. Is it okay if someone, instead of writing that, someone wrote 300 joules per second? Do you think that is okay? My answer is yes. It is very okay. So, as we summarize, I'm very sure, let me summarize from this side. I'm very sure we have met our learning objectives, right? Being able to define power, the unit of power, we have talked about it, what the watt means. We have also looked at the relationship P equals W over T. And we have also seen how to use it in an equation. So thank you for being wonderful students. Stay safe until we meet again. Remember, the previous work that I told you that I'm going to leave you with will remain on the board. Bye-bye.